Now we are going to discuss about the elementary operations of a graph. So in order to understand the elementary operations on a graph, we need to have a basic understanding of what is meant by a graph. So in the previous classes we have discussed about the graph. Again I am rememberizing the things. Graph. A graph is a collection of two sets. What are those two sets? Vertex set and edge set. So what is meant by vertex set? It consists of vertices and is represented by capital V. What is meant by edge set? It consists of edges and is represented by capital E. So a graph is represented by capital G is equal to capital V comma capital E. Let us understand what is meant by a vertex and what is meant by an edge. So in this example, a circles are there. No, this is one circle, this is another circle, this is another circle, and this is another circle. For this circle, we are giving the name as V1. For this circle, we are giving the name as V2. For this circle, we are giving the name as V3. For this circle, we are giving the name as V4. How many vertices? How many circles are there? 4 circles are there. So these are called as the vertices. A vertex is represented by a circle in a graph. So what are the vertices? V1, V2, V3 and V4. There are lines are there no here? But there is a line from V1 to V2, there is a line from V2 to V3, there is a line from V3 to V4, there is a line from V4 to V1 and from V1 to V5. So does there exist an arrow mark on the line or not? So there is no arrow mark between these lines. So simply a line is there, not from V1 to V4, the arrow mark is not there, or V2 to V1 there is no arrow mark. So here if there exists arrow mark on that is if there exists a direction on the line, then it is called as a directed graph. If there does not exist any direction, then it is called as an undirected graph. So this is called as an undirected graph. So what is this one? A graph is a collection of two sets. What are those two sets? Vertex set and edge set. So what is this vertex set? It consists of vertices and is represented by capital V. What is edge set? It consists of edges and is represented by capital E. A graph is represented by capital G is equivalent to capital V comma capital E. Capital V is set of vertices. In the diagrammatic form, how we are going to represent the vertices? Vertices are represented by the circles and the edges are represented by the lines. So vertices means names are here V1, V2, V3 and V4. What are the edges? Lines are called as the edges. E1, E2, E3, E4 and E5. Now I am representing this entire graph in the notation form. Capital V is equal to how many circles? 4 circles. What are the names of 4 circles? V1, V2, V3 and V4. V1, comma, V2, comma, V3, comma, V4. So this is a set of vertices and this is represented by capital V. What are the edges? E1, E2, E3 and E4 and E5. How many edges are there? 5 edges are there. I am representing it as a set. The capital E is equal to E1, comma, E2, comma, E3, comma, E4, comma, E5. So this is a description about a graph. A graph is a collection of two sets, vertex set and edge set. Vertex set consists of vertices and it is represented by capital V. Edge set it is consists of edges and is represented by capital E. A graph is represented by capital G is equal to capital V, comma, capital E. So this is about the graph and example for the graph. What are the diagrammatic representation of a vertex? Circle. What is the diagrammatic representation of an edge? It is a line. If direction exists, then it is called as a directed graph. If direction does not exist, then it is called as an undirected graph. Now we are going to discuss about the elementary graph operations. What are the different graph operations? So what operations can be done on a graph? So what are the different operations? Adding a vertex, deleting a vertex, adding an edge, deleting an edge, contracting an edge, constructing a subgraph, constructing a spanning tree, complement of a graph and transpose of a graph. These are all called as all or not elementary operations. These are all the elementary operations. Adding, deleting, adding a vertex, deleting a vertex, adding an edge, deleting an edge, contracting an edge, constructing a subgraph. So these are the somewhat advanced operations that is called as the spanning tree construction, complement of a graph and transpose of a graph. All are combined together and then we are going to discuss in the elementary elementary graph operations. Adding a vertex. The first operation is called as the adding a vertex. Let us consider the following graph. So we have taken one graph for example. So here circles 1, 2, 3, 4, 4 circles are there. For this circle, what is the name? V1. For this circle, what is the name? V2. For this circle, V3. And for this circle, V4. How many lines are there? 4 lines are there. What are the names of those lines? E1, E2, E3 and E4. This is a graph. Adding a vertex to this graph. So this is a graph. Vertex means a circle. I am adding one more circle. I am giving name for that particular vertex V5. But I am not keeping any edge with the new vertex to the existing vertices, and hence this is called as an isolated vertex. We are going to call this as the isolated vertex. Adding a vertex, this is an existing graph. For this existing graph, I am adding one vertex. Vertex is represented by a circle and each vertex is represented by a name. That's why I have kept it as V5, and I have not kept any edge from the existing graph to the new vertex, and hence this vertex is called as a isolated vertex. Let us have adding an edge. Now I am going to add an edge for the new vertex to the existing graph. So this is an already existing graph. This is a graph we have taken now. So this is an existing graph V1, V2, V3, V4. Already one more vertex we have added without a connection with the existing graph, and hence it is called as an isolated vertex. Now I am going to add an edge from the new vertex to the existing graph, that is represented by E5, and this is called as adding an edge. So how many edges? 4 edges are there previously. Now it is going to contain one more edge E5. Previously how many vertices are there? 4 vertices or 5 vertices are there. Initially 4, after that 5. This is 5. Now 5 vertices, one more edge has been added. This is an adding a vertex and this is an adding an edge. Coming to the next one, deleting a vertex along with its edge. Now I want to delete a vertex along with its edge. Now what we are going to do, this is a graph. One more example I have taken, that is V1, V2, V3 and V4, V5. So V5 I have drawn within the middle of the graph here. So E1, E2, E3, E4, E5. Next one more edges I have taken. Now I want to delete this vertex along with this edge. So deleting a vertex along with this edge. Next, what is meant by contracting an edge? Next, so if you delete only the vertex, then this edge cannot exist without this vertex, and hence we have to delete this vertex along with this edge. So coming to the edge means it is a connection between two vertices. Compulsorily a line should connect two vertices. If only with one vertex we cannot draw a edge. So next one is contracting an edge. So there are 3 vertices. One is there is a U, V, W. Now what we are going to do? Next I want to contract an edge. This edge I want to take it off. Then directly what happens? These two, this and the entire thing is going to be shrinked, and these two vertices are going to be taken as a single vertex, that is called as the X. This exists UV. This is U, this is V. This is an edge. These entire two vertices are combined together to form a single vertex. We are going to get it as a single vertex X, and then we are going to use the W. This is called as contracting an edge. Then one is constructing a subgraph. How to construct a subgraph? How we are going to construct a subgraph? Before constructing a subgraph, next we have to understand what is meant by, before understanding the subgraph, we have to understand what is meant by subgraph. So this is a main graph. This is the main graph we are going to have V1, V2, V3, V4, E1, E2, E3 and E4. Now subgraph is a graph which is obtained from the existing graph by deleting some vertices and some edges. We can delete some vertices and we can delete some edges. Then such type of graph is called as a subgraph. So G dash, now I am constructing a G dash. How many vertices? V1, V2, V3, V4. 4 vertices in the original graph. In the subgraph I am taking V1, V2 and V3. 3 vertices. 1 vertex I have deleted. And then E1, E2, E3, E4. 4 vertices edges are there. Here I am keeping only 2 edges. So G dash is a graph which is called as a subgraph of G, since V dash is subset of V and E dash is subset of E. Subset, you know, here what is the vertex at here? V1, V2, V3. Here what is the vertex? V1, V2, V3 and V4. Here V dash is subset of V and E dash is subset of E, and hence G dash is called as a subgraph of G. Then coming to the next one is called as a constructing a spanning tree. How to construct the spanning tree? So what is meant by a spanning tree? In order to understand this, we need to have a basic understanding of a tree. So what is the difference between graph and a tree? A graph without cycles is called as a tree. So let us take this graph V1, V2, V3, V4. If you start at V1, we can go to V2 and we can go to V3 and then we can go to V4 and we can come to V1. So there exists we will start at a particular vertex and we are going to move around the graph and we are coming back to the original vertex. Hence this is called as a cycle. We are going wherever we are starting, we are going along the graph and we are coming back, and hence it is called as a cycle. So this is a graph with cycles. Graph without cycles are called as the trees. Graph without cycles are called as the trees. So what is meant by a cycle? If you start at a particular vertex and if you are going to move through along some edges and if you are able to come back to the same vertex, then it is called as a cycle. So now we have to construct a spanning tree. So what is meant by first graph we have discussed, and then we have discussed about the tree. A tree is a graph without cycles. Then what is a spanning tree means? How many vertices are there in this graph? 4 vertices. Same number of vertices has to exist. Edges can be removed. Cycle should not be formed. 3 conditions. How many vertices are there in the original graph? Same number of vertices has to be retained. And then we have to delete some edges. We can delete some edges. There is no problem. Cycle should not be formed. So if you observe V1, V2, V3, V4. 4 vertices in the graph. 4 vertices in this graph also. And I have removed one edge. There is no cycle. You check, there is no circle will not be formed here, and hence this is called as a spanning tree. Here also 4 vertices, one edge has been deleted and no cycle is forming here, and hence this is called as a spanning tree. This is one more spanning tree. A spanning tree is a subgraph which contains the same number of vertices as the original graph. Whatever number of vertices that exist in the original graph, same number of vertices should exist. Cycle should not be existing. Then such type of things is called as a spanning tree. We are going to call this as a spanning tree. Coming to the next operation, that is called as the complement of a graph. How to define the complement of a graph? So let us take this as a graph. V1, V2, V3, V4, V5. 5 vertices are there. This is a graph. Some edges. I have taken 1, 2, 3, 4, 5, 6 edges. So now same vertices we have to keep. Complement also contains the same number of vertices. V1, V2, V3, V4 and V5. So here whatever edge here that exists, that should not be kept. Whatever edge that is not existing, those edges we have to keep. V1 to V1, V2 already there, no, we should not keep. V1 to V3 we should not keep. V1 to V5, there is no edge here. That's why we are keeping V1 to V5. V1 to V6, there is a V1 to V4 also, there is no edge. So we are keeping V1 to V4. And then there is no edge between V2 to V4 and V3 to V5. So whatever same, here 5 vertices are there, here also same 5 vertices we have to keep. And whatever edges that exist in the original graph, those edges should not be kept here. Whatever edges are missing in this graph, those edges has to be kept here. That is called as a complement of a graph. And then next one is called as a transpose of a graph. If you observe this transpose of a graph, what here, if you observe, this is a directed graph, because on the edge we are having the arrow mark, and hence this is called as a directed graph. On this graph, this is a directed graph. Now I want to find out the transpose. So simply change the directions of the graph. Here there is a direction from C to A. You change it to from A to C. From A to B there is direction. You change it as B to A. From B to C there is direction. You have to change it as C to B. From here to here we have to change the direction. If you change the directions, we are going to get like this. This is called as a transpose of a graph. So there is a lot of difference between complement and transpose. Transpose exists only for the directed graphs, whereas complement exists for the undirected graphs. What is the meaning of a complement of a graph? The complement of a graph is a graph which is assigned from the original graph such that it contains the same number of vertices as the original graph, and whatever edges that are missing in the original graph, those are going to be retained in the complement graph. Such type of graph is called as the complement of a graph. Transpose of a graph means it is existing for the direct graph. What happens? Directions in along the edges is going to be changed, means then it is called as a. Here also how many vertices? 5 vertices are there. 1, 2, 3, 4. 4 vertices. Here also we are having the 4 vertices, but directions will be changed, and hence this is called as a transpose of a graph. So these are all called as the elementary graph operations: adding a vertex, deleting a vertex, adding an edge, deleting an edge, contracting an edge, constructing subgraph, constructing spanning tree, complement of a graph, transpose of a graph.